Hi, my name is Jaime, and today I'm going to go over my programming concepts final, Laser Knight. So at the very beginning of the game, obviously you get some text, and then you come with the rules. If you put in any input other than the inputs that are required, you'll get returned invalid responses. So in this case, yes, we would like to see the rules. And then it allows player 1 to choose the shape. So in this case, we're going to go triangle, we're going to do random, and red, and then rectangle, red, and then blue. And then it creates the shapes. And then it allows player 1 to choose their move, and then player 2 to choose their moves. And briefly, I'm running through every single attack pattern, just to demonstrate that it works. I've added flavor text to every scenario that comes up, just to add a little bit to the essence of the game and hopefully make it a little unique. As soon as one player dies, the other player wins the duel, so they get congratulatory text on the top and they get some flavor text at the bottom. So next up, we're going to go over the code itself. So my code is broken up into a couple different sections. The first section is the welcome message and the customization. For every customization, there's an input function that creates the text that you see. So would you like to see the rules? Yes or no? And then based on that response, if it is not one of the valid responses, so say it's not no or not yes, then it'll repeat an invalid response. Please try again. So at every point in the game, when you can input things, it's inputted through this input function, setting a variable. And there's a while function attached to it. So again, player 1 color, there's a while function, player 1 laser color, etc., etc. So player 1 settings, player 2 settings. Next up is the plots. So at the very beginning, I have some pre-allocated variables, and then I have the colors. I'll go into more about the colors during the laser charging section because it brings out more, but essentially the colors get pre-allocated to a matrix, an RGB matrix, 1x3. So next up, we have the plotting. So for the specific players, obviously there's two options. You can either be a rectangle or a triangle. It creates an outline if you're a rectangle or a triangle based on the X and the Y. And so these are all based on the gaps and the shape heights, which means that if I adjust the actual specific gap or the shape width, it will adjust the corresponding rectangle and triangle. And then the inside has a fill. So the fill also has most importantly, the fill has a Y vector that gets adjusted based on the percentage of health. So in this case, the shape height multiplies by the shape health. Divided by 4. So, because that's the total amount of health that you can have. So obviously if you have 2 out of 4 health, well, you're going to have half the height. And the same thing happens for the triangle, except in addition to the height in addition to the Y that gets adjusted, the X also gets adjusted. Over here you can see, because for the triangle, you're actually creating a trapezoid in order to fill in the area of the triangle instead of a regular triangle. So next up is the attacks. So all of the attacks are run through the attack matrix, essentially. So while both players' health are greater than 0, there's some pre-allocated variables again. It's a giant, again, so here is how the actual inputted attacks are taken in. So P1 attack is input, and then while that input is not one of the valid ones, it'll tell you to redo it, etc. So it's essentially two giant if-then statements based on player 1's inputs and player 2's inputs. So the outside one is a P1. So if P1 is quick attack, if P1 is charge laser, and if P1 is recoil shield. And then inside of that are the specific values for P2. So if P2 does a quick attack, then this happens. If P2 does a charge laser, then this happens. And then if P2 does a recoil shield, etc., etc. So within these smaller things, so I call them scenarios, right? Within these scenarios, a set amount of things happen. So first, you have some flavor text. Again, flavor text just for the viewer's sake. Then you have an animation. And then, if it requires, you have a health update. So the health update just recreates the fill for the shape based on the new health, because the health gets adjusted. And for efficiency's sake, only the player whose health was adjusted gets a refill on the graph, essentially. So, first up, I'm going to talk about the quick attack. For the quick attack, it's just a single point with a marker, with a circle marker, size 25, that gets moved along the graph, essentially. For all of the animations, they use something that I called animation time, which essentially works as a clock that goes from 1 to 100, and it's the frames, essentially. So, if the ball is not at the other player's border, or if the ball has not reached the other player, then it will continue to increase its distance. It'll continue to move along. Yep. So every animation goes by frame. So the frame starts, then the plot, then it pauses, and then it deletes the previous plot so that it can start back up at a new frame. So for the quick attack over here, these are two quick attacks that are getting met at each other, so they only have to go up until the halfway point. So that's 2 times the gap plus the shape width. And then after that point, they delete each other. They delete themselves. If player 1 does a quick attack and player 2 does a charge laser, well, the quick attack beats the charge laser by going all the way to the end. So again, the ball just continues on until past. So over here, instead of 2 times the gap plus the shape width, it's actually 3 times the gap plus the shape width. So that allows it to go all the way to the end, and then it deletes itself. That leads us conveniently to the laser. So over here is the charge animation for the laser. All of the lasers share the same charge animation, but they don't necessarily share the same attack animation. So for the laser, the charge animation is just a fill in front of it with a base height. So it's a rectangle fill based on the shape width that has, over here, an RGB matrix attached to the end. That RGB matrix gets determined which value gets adjusted based on which one was chosen at the very beginning. So if you chose a red laser, well, then you adjust the red part of the RGB matrix. If you chose green, blue, etc. So the laser value is based on the animation time. It starts at 0, and then it increases based on the animation. So once it reaches past 25 frames, then it turns back to 1, because if you put in any RGB matrix a number higher than 1, you're going to get an error. For the laser that continues on, that actually continues the attack, it's the same thing. It's a fill. However, that fill adjusts its width depending on the animation time. So that lets it continue all the way to the other end. And over here, these are static. So these are just 1. Because by this point, the laser value is already 1, so there should be no difference. The charging using the laser value allows it to go from 0, so black, to the color that was chosen. I just wanted to clarify that again. So then at the very end, after every frame, it deletes it and then allows it to re-put. And then for the shield is just a single fill animation, or not a fill animation, a fill plot that happens before the animation and then gets deleted after the animation. And then at the very end, you have an ending animation. This ending animation triggers if one of the players' health is 0. And then for whoever's health is 0, the other one wins. So if player 1 health is 0, well then player 2 wins. You get the flavor text. And then for the actual animation itself, it's just deleting the plot line or the outline and then adjusting the outline to shape -1 or shape height -1. So it's just shrinking the height itself. It's not changing the actual X value itself. And that's it. Thank you for reviewing my project. I hope you have a good time. Thank you.